Hello everyone, welcome to Matplotlib. As in a previous session, we discussed the different types of plotting using Matplotlib 3D. So today we'll be moving to the one of the new concept called surface triangulation. We already saw how we have to create a wireframe and surface. So we'll continue with the same way from there only. Suppose you need to start from the starting, so you need to take all the values from here. So we already see that in the previous sessions, like how we have to take this values. So we just jump directly here to take in the other values to using this particular triangulations. Basically this application we evenly sample the grids required by the above routines in overly restrictive and inconvenience in this situation. So in that particular situation, what we do, we use the triangulation. That's why it's called surface triangulation based plotting can be very useful. So to reduce those issue, what will happen in a restrictive inconvenience when you use this thing, we move to the this particular, which is rather even a draw a Cartesians on a polar grid, we instead of set the random draws. So let's start that how you have to use this particular uses this. Moving to theta equals to 2 into np dot pi and into np dot random dot random dot random, and then moving to the 1000. Yeah, so we already done with this particular. Let's move to r values. R equals to 6 into np dot random because we are taking the random values. So for this random np dot, we already imported numpy, so we can use directly. If you won't import it, you should import all those features, then only use it, or else it will give you the error on that, because I'm using the same folder for this one to create it, which already I importing this, so it will not show me because it's a continuous thing. So if you are not using the continuously, you should just import it all the things before to use this features. Random, let's move to 6 into np dot random, let's move to 1000. So we just give the values. Let's move to r is done. Now xyz, because 3 x's are there, we need to create that xyz. Let's start with the first x. So x equals to np dot ravel, revel. This is one of the method called ravel. We are using those method to use those particular things. It's just using to create like a scatter type of thing. We use ravel also. So r into np dot sin of your theta, which is already created, and then we are going with the y. This is for the same, we use a cos. Y equals to np dot ravel, and then we are going with r multiply by np dot cos, and then we are going with theta. So just cos and sine changes are there, x and y, and z is method. Already we created the method, that you won't confuse. We already create this particular method, so it's run properly. fxy, when we are doing the other methods, we create this particular div, right? So I just show you once the div. Here is the div. So we created that particular div, so we just directly use it here. And let's move to create the scatter views of that particular. Now we should use to create scatter plots for this point to get an idea of surfacing. We are sampling for this, is called a sampling the things. So moving to ax equals to plt dot axes, and then moving to projection equals to 3d. So our projection is 3d. Then move it to scatter. So ax dot scatter, and then just now we created x comma y comma z, right? We already going with that. C equals to z comma c mapping. For the mapping, how we need to see that, so I just going with the VIRIDIS, where it is like multiple of color together, and then going with the line width. How much the line width you wanted? WIDTH, line width equals to 0.5. So we done this. So just wait a while, you will get that output of the scatter plates, like how we used it with the help of Viridis, because we use Viridis for the SEMA, and we give the white, and you can observe it comes to this in this way. This is the one plotting. So this leaves a lot of desired the function that will help you the case of your plots of Tirusov. So there is one method called plot true surf, like because we are working on surface triangulation, so we use the method called true surf. So with the help of that, what happened, like when you use this particular surf, it's first finding the set of triangles, like how many triangles we can make it with the xyz, and it will be created. Let's see and create that. Like here it will find like this, you can get one triangle, so how many triangle it can be used. That's why its name is surface triangulations. So let's use that. Ax equals to plt dot axis of projection equals to 3D. So this will be done, the 3D projection is done, and going with ax dot plot, because we have to plot it. Which plot? Triangulation. So the shortcut, the methods we use TRISURF. This is a method named true surf because surface triangulations. And then moving to the values x comma y comma z, and then C map equals to the colors. You can go with any other things also, Veritas, if you don't want. That's like wish, Veritas, another C map, which color we can map it in a which particular area. Then edge color, COLOR, edge color equals to none. We give none. We can run this particular, wait for a while. Yeah, you can observe wherever they got the triangle, they created the triangle V. So that is the main thing. And this the result. In a result, what happened, whenever the certainly it's clean it, and wherever they feel like that the plots are there in 3-dimensional way, as well as when you believe like it comes to the squaring way, like the triangle. So before using the surface triangulation, what happened, it's give you the dot scatter. We uses the dot, we use the scatter method, so we give the dots way. So now with the help of dot, they will search it from where the triangle can be done. So they move to that particular triangle, and it gives this triangle. So we use a method called tree surf. So this is how you'll use the 3D plotting in your Matplotlib. Thank you.